Okay, so circuit diagrams, sort of the sum of all the things we've learned in circuit diagrams, although we didn't include all the various types of switches we've dealt with, which is the most simple switch. These are the basic things. So we have a battery, wires are just lines, resistor, bulb, which is a special kind of resistor, junction is just any line that connects together. Okay, so be careful you don't draw lines across each other that aren't actually connected, because that's not kosher in a circuit diagram. Capacitors, which are not to be confused with batteries if you draw them weirdly, and switches. Okay, so here's the most basic type of circuit, and we can use sort of this water flowing analogy, just like we said with current, right? Flow rate of water is the same everywhere. Current is the same everywhere in a loop. A potential difference can be thought of as a change in elevation, right? So if you want to give potential energy to water, you have to pump it up to a higher location, okay? Current can be considered water flow rate, right? It's not the speed of the water, it's the total amount of water molecules that go past a particular point at a particular time, all right? Resistor could be considered a waterfall, right? If you put water up high, you can drop it down to a lower potential or potential energy by changing its elevation down. So batteries and power supplies move charge up, right, to a higher potential energy. Resistors and other things that put load on your circuit bring it back down, okay? And then a battery can be considered a water pump. So over here, we can say we use this to pump the circuit stuff up to a higher potential. So like if this is a battery that starts at, let's say, 0, it doesn't have to be 0, it's only 0 if it's grounded. We'll talk about that later. But this is a regular, like, AAA battery. This is 1.5 volts. Your current is flowing the same flow rate until it gets to the resistor. Then it drops from 1.5 volts back down to 0, flows back over here. The current everywhere in this circuit should be the same because it's just one loop. Okay, no junctions, all right? Nothing has split off. So, for instance, okay, we can see here that we have a resistor, a capacitor, a battery, and all of them seem to be in parallel with each other. That means they all share these two junctions, okay? So you can see there's a junction here at the top of the battery, and there's a junction here that connects to the bottom of the battery. And what that means is wires going from the top of the battery go out to the capacitor and the resistor, and wires going from the bottom of the battery connect to both the capacitor and the resistor, okay? So now that we've sort of established all that, let's remember the symbols for resistors. So the symbol for a resistor looks like this, okay? This is a resistor. The symbol for the capacitor looks like this. And the battery symbol looks like this. So there's lots of different ways you can draw this, but remember when you're drawing circuit diagrams, the main thing you want to keep in mind is, one, where the junctions are, and two, make it clean. So you want to make this easy to read so that if you're building the circuit, it's not super confusing, okay? So if you want to draw it sort of literally, you draw the resistor, the battery, and the capacitor, okay? This is fine because you can see here we have a resistor, we have the battery, and we have the capacitor, and they look exactly like this. And you can see here's our junctions, one here, one here. So all three of these things are in parallel. It looks just like the picture. But when you're drawing a circuit diagram, it doesn't have to look like the picture. So you could start with the battery here, as long as you keep the orientation of the battery the same. You could put the resistor in the middle, and you could put the capacitor over here. You could also put the battery here, put the capacitor in the middle, and put the resistor over here. So you can rearrange these things, but the main thing we want to keep in mind is these junctions are still the same. We still have 3 circuit elements in parallel with each other, even if we draw it different ways. I mean, you could even draw this as a triangle shape, so you could have something like this. You have your battery in the middle and your capacitor over here. This is the same circuit, and if you were building these circuits, they would all function the same way because you can see the junctions have been preserved and you have all the circuit elements. The only thing to really keep in mind is make sure that your battery is always facing the same way relative to the other circuit elements. In this case, it's not going to matter too much because these other circuit elements aren't directional, meaning it doesn't matter which way the current flows through them, so the functionality of the circuit won't really change. But in later situations, you'll find that these other circuit elements we're going to learn about will care which direction you're going, especially as you get on to more advanced circuits. And so it's a good practice to always remember where the positive side of the battery is. Okay, so just to recap, you always want to make sure that your junctions are in the right place, so look on your original circuit for where the wires split, okay, and make sure those are preserved. Remember, everywhere along this wire and everywhere along this wire, it's like it's all connected. So no matter how you have it connected, it's still going to function the same way. Same with this, okay? So all of these circuits are the same. The only thing you wouldn't want to do is draw something in series because nothing in this circuit is in series. All right. So now that we've done an example, it'd be really nice if you could try to draw one of these yourselves. So we're going to pause here, and you should pause and look at this problem and try to do it before watching the solution. This is for your own good. All right, if you've tried that, now you can move on. So, just like before, we're going to be looking at where the junctions are, what the circuit elements are, and how we should draw this. So remember, we want to make sure that we draw a circuit diagram as simply as possible. So we're going to start by looking at this first circuit, and we're going to say, okay, this is a resistor, this is a resistor, and this is a resistor. All right, and then we have batteries. So this is our battery. And we remember that resistors look like this and batteries look like this, okay? We also notice that there are some junctions. There's a junction here and a junction here. So how you would talk about this is you would say this resistor is in series with nothing. It is in parallel with the battery, okay? These two resistors are in series with each other, and this whole thing as a whole is in parallel with the battery and with this other resistor, okay? So I know that's a lot to keep track of, but really we just want to draw it out. So we first draw our 75 ohm resistor. Then we draw our battery, making sure the positive direction is the same in the circuit diagram as it is in the picture. And then we're going to draw our two resistors that are in series, so 50 ohms and 100 ohms. Okay, and here's our 9-volt battery with a positive side here. Now, we need to blow this up so you can see it better. Okay, so like we said before, here's our junctions. They match the junctions we showed up here. So we know these 3 branches of the circuit, and a branch, remember, is anything that's connected by one wire that doesn't split. These 3 branches of the circuit are all going through these 2 junctions, okay? So we have the junctions, we have our resistors, 1, 2, 3. We kept them in the same order, so the 75 ohm, 50 and 100. 50 and 100 are in series, 75 ohm is by itself, and then last but not least we have the battery.
Okay? There's another way you could draw this. So we're going to try it. The other way, which would work just as well, is to start with the battery. And then we have one resistor by itself and two resistors in series. And then we can label everything at the end. So here's our 9-volt battery. We know the positive side's here. We have a 75 ohm resistor, a 50 ohm resistor, and a 100 ohm resistor. Just like before, the main things we have to check, well, we have two resistors in series, one that's in parallel with the ones in series in the battery, and we have our 9-volt battery. The main thing to remember is everything looks clean, and we have these two junctions that are in the exact same configuration as they are in the diagram. Okay, so that's our first circuit. Then our next one is a little less straightforward. So this guy over here, we have an extra circuit element. So just like before, we have a couple of resistors. We got a battery, this time that's a 12 volt. And now we also have a capacitor. So we just have to remember how to draw a capacitor. A capacitor looks like this, not to be confused with a battery. Okay? So once again, we're going to look for the junctions. We can see that there are junctions here and here. So how many branches are there of this circuit? Well, there's one, it just goes through this resistor. 2, that goes through the battery and the resistor. And 3, that just goes through the capacitor. Okay, so let's pull that back. But we have 3 branches and 2 junctions just like before. So we just want to make sure the junctions and the branches are laid out the same. So we have to have 3 separate branches connected by 2 junctions. So we'll start with the battery, but the battery in this case, we'll start down here, because the battery is in series with a resistor, and it's the 50 ohm resistor. So we could say 50 ohms, and then here's our 12 volt battery. Then we come to our first junction, and it actually doesn't matter if you pick the resistor or the capacitor at this point. It'll give you the same thing. And then we have one more branch with just one resistor. So here's our 100 ohm resistor, and here's our 10 microfarad capacitor. Okay? And just to review, we have 2 junctions, we have the 3 branches, we have a resistor here and a resistor here. The 50 ohm resistor is in series with the battery. The whole branch containing the 50 ohm resistor and the battery is in parallel with both the 10 microfarad capacitor and this 100 ohm resistor. Okay? So you can rearrange the branches, but you have to make sure that you preserve these junctions. All right.
Okay. So yeah, these are the general ways to draw these, but remember there's lots of variations on this theme that are still okay. So let's try that out. Let's discuss
B and
The other
C
one,
what's the
look
difference
the
between
same.
B
Well, they're all in parallel, right? So B, A and D are the same, but that wasn't an option.
Right.
I knew A and D were the same. I just didn't know about.
So B is also parallel, right?
Yeah, I didn't. Since it wasn't.
It's gonna be
So
a
that
run of
one's
the
in
mill
parallel.
Stone.
well, don't let the placement confuse you.
Yeah, see the
You can shift it over to the right,
the
right?
capacitor.
And you
The
can see,
capacitor is the one that messed me up.
yeah, but you can easily shift it over to the right.
To
and
the
see
right,
it.
and it's the same.
Parallel.
All right, you got about 6 more seconds to think about this.
Resistors. It is here. Yeah, well, that one should want you to know that.
Oh wow. Okay. Well, we nailed it. And remember, the important thing is where the junctions are, right? So here, junctions between all 3 circuit elements. Junctions between all 3 circuit elements. There's not a junction between the battery and the resistor here, and now there's a, what is this called?
Short.
A short. So it's almost like this thing doesn't even exist, because where is the current going to flow? Through here, okay? Path of least resistance, literally, okay? Because we're dealing with resistors now. And this one's a weird shape, but you can see the junctions are between everything. So, yeah, that's where we're at. A, B, and D, all the same. C, not great. Okay. Here's another. Photograph them, steal their soul. Yes, we're gonna just leave it at that. So, unless you put B, you're right. You can see the junctions, right? There's a junction right after this battery. These